This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Hi there. Today we're going to graph quadratic functions. We can write a quadratic function in vertex form. For any quadratic function f of x equals ax squared plus bx plus c, we can rewrite it as a multiplied by the expression x minus h squared plus k. We can use this form to graph a parabola. First, a can tell us whether our graph opens up or down. If a is positive, the graph opens upward, and if it's negative, the graph opens downward. H and k give us the vertex of f of x, hk. The vertex is the point where the graph changes direction. Let's try graphing parabolas using what we know about vertex form. Graph the function f of x equals 2x squared. Let's first start by putting our equation in vertex form. X is the only term being squared, so we can rewrite it as x minus 0 squared. The equation doesn't have any constant terms, so k equals 0. Now we're in vertex form. What does our equation tell us? First, a is positive. Our graph opens upwards. Next, h equals 0 and k equals 0. Our vertex is 0, 0. Now we have our vertex and we know the graph opens upwards, but we need a little bit more to actually draw our parabola. Let's choose an x value to plug into our function so we can plot another point on our parabola. Let's use x equals 2. When x equals 2, f of x equals 2 multiplied by 2 minus 0 squared plus 0. That simplifies to 2 times 4 plus 0, which equals 8. Thus, 2, 8 is on the graph. We also know that our parabola is symmetric about the vertical line through our vertex, which in this case is the y-axis. So since 2, 8 is on our graph, negative 2, 8 will be as well. Now we can plot our parabola. Here is the graph of 2x squared. Let's do another example. Graph the function f of x equals 5 multiplied by x plus 3 squared minus 1. This function is not exactly in vertex form. The expression inside the square is a sum. Let's rewrite it as a difference. Adding 3 is the same as subtracting negative 3. Now it's in vertex form. Let's compare. First, a is positive. Our graph opens upwards. Next, h equals negative 3 and k equals negative 1. Our vertex is at negative 3, negative 1. Now we need an additional point on our parabola. Let's plug in x equals negative 2. That will make the number we're squaring small, so it will fit on our graph. When x equals negative 2, then f of x equals 5 multiplied by negative 2 plus 3 squared minus 1, which works out to 4. Negative 2, 4 is on our graph. The symmetric point on our parabola is negative 4, 4. Now we can plot. Here is the graph of f of x. Graph the function f of x equals half x squared minus 4x. This problem is a bit different from our previous two. It's written in the general form of a quadratic. How can we turn it into the vertex form? By completing the square. First, factor out half from the x terms. That gives us a half of x squared minus 8x. Next, what term can we add to x squared minus 8x so that it is a perfect square trinomial? 16, because x squared minus 8x plus 16 equals x minus 4 times x minus 4, which is x minus 4 squared. Notice that we have a box outside the squared term in the expression. Since we added 16 inside our parentheses, we have to subtract the equivalent term, half of 16, outside our parentheses to keep the value of the equation the same. Outside the bracket, a half times 16 equals 8. Our equation in vertex form is x minus 4 squared minus 8. Now we know how to graph this. A is positive. Our graph opens upwards. Next, the vertex is 4, negative 8. Finally, if x equals 2, then f of x equals negative 6. 2, negative 6 is a point on the graph. Its corresponding point is 6, negative 6. Here's the graph of f of x. Great job graphing quadratic functions today. Keep practicing.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.